In this series of videos I'm attempting to repair and restore this HP9845B vintage computer. So far in this series I've carried out a number of repairs, been through the main chassis, the power supply, the two processors, ROM cards, found quite a number of faults and ultimately got it to the point where it was starting to boot up. But I still had issues. I moved on to the internal printer, so thermal printer, and this is quite an interesting part of the machine, and it's posed a bit of a challenge getting it working. You can see I have made some progress with this. So at the end of the previous video I got as far as testing the modules, the driver modules in the print head itself. There are 7 of them and only 1 was working. I have since got another 2 of them working, and I've got 2 more. I know 2 of them have failed completely. I've got 2 more I may be able to repair, but I'll post a separate video on how I'm going about repairing those. And I'm sure you're all getting a bit bored with the printer at the moment, so I'll just briefly touch on how far I've got with it in this video, and then we'll move on to some other repairs I've been carrying out. So I got as far as getting the first module working, got the 2 driver boards working, a number of faults on those, and finally got some output from the unit, and I'd found that amongst other faults the 2 RAM chips weren't working properly, and to get it printing at all I swapped them over. I didn't have any spares at the time, and that started it printing. But I was getting fairly odd results when I tried to print. So I was getting characters being incorrectly replaced. Now there is quite a complex arrangement in selecting the character that will be printed in this particular printer. It allows substitution of certain characters. But what I was seeing was this. So I printed, in this case, hope you can see this, I printed 10 print quote mark hello world quote mark, and you can see this is what came out. I've got the monitor fitted, we'll look at that in a few minutes, and it was showing the correct text on the monitor, but the printer was printing some different characters, and it was fairly consistent in the way it did that, and it really depended on where in the line particular characters fell. It's not because the H was always wrong. If the H appeared in other places it would print it correctly. You can also see that as the lines got longer we started getting some weird behavior at the beginning of the line, and then we got missing characters. So this should say improper expression, and you can see it's got the wrong text. Numbers were coming out fairly strange, you had odd characters in them, and it kind of looks a little bit like it's a fault with the printer driver. But it's not. This was actually caused by the RAM chips on the control board, and so I went through a number of tests, and you can see, as I said, it's fairly consistent in the way it would substitute certain characters. But ultimately at this point I decided to replace the RAM chips. The spares I'd ordered finally turned up, and it is now printing correctly. So I'll zoom you in. I will try printing a bit of text, and I'll show you how far I've got in repairing the printer. So as you can hear, I've got the HP powered up. I've typed in the command to direct all output to the printer, and if I now just type in some random characters and then hit execute, you can see we are getting output, and it's the correct output. I can't wind the paper out, I still don't have the paper advance key plugged in. It does work, I've just removed it so I don't damage the fairly fragile plastic plate that it's attached to. But hopefully you can see, if I just feed out a bit more paper, you can see that it is now printing the correct characters. Looks like garbage, but this is what I've typed in, and it does match what's on the screen. It's not going past, of course, character 34, because I only have 3 of the driver modules working, and each one handles just over 11 characters. But they are now working correctly, apart from one missing bit. I've got one bit on the first module that's not working, but I can live with that. It's certainly a lot better than it was. If I can get 2 more of the modules working, then 5 out of 7 will give me a reasonable printer. It'll work fairly well. It'd be nice to have all 7 working, but 5 is certainly better than 1, and it does make it reasonably useful. So, as I say, the faults, apart from the ones we'd already looked at, were just the 2 RAM chips. I've actually fitted AM9112 devices. They were easier to get than the P2112s, and they are equivalent, and as you can see, they work just fine. So now that I've got the printer partly operational, I still have work to do, as I said, on trying to get a few more of the modules working, but I thought I'd have a bit of a change and stop getting too bored watching video after video on just the printer. So I wanted to try and run some test code. It's now got to the point where I should be able to run some test code on this. So did have the test ROM, so I put that into the PPU ROM drawer, fitted this and put this into the machine, but unfortunately it didn't work. Didn't recognize the ROM being fitted, and what it should do is, with this particular ROM cartridge fitted, because of the way it's mapped, the system at boot up looks for this, and if it finds it, it should branch to the test routines that are inside this ROM. But it wasn't doing anything, it wasn't making any difference, it wasn't hanging the machine, it just wasn't recognizing the fact that the module was plugged in. Tried it in different slots and it did the same thing. It needs to go in one of the first slots. And I put the logic analyzer back onto the HP and found that although it was trying to properly access the ROM module in this drawer, it wasn't getting any response from the module. And at first I thought it was a faulty module, but I tried some other zero type modules or circle type modules, and they did the same thing, and I don't think that they're all faulty. So I assumed it was a fault within the drawer itself. There's not a great deal in here, it's mostly just some buffer chips. So I took this apart, and sure enough I found that one of the buffer chips was faulty. I'll just take this apart and let you have a look inside. There's not a great deal in here, but if you're interested, we'll have a quick peek inside and see what's in there. So I've removed the 6 screws that hold this together. We can now just take the top cover off, and then the PCB will lift straight out. So you can see there's not a great deal in here, it's mostly buffer chips. You can see the one I've replaced, I did put a socket in. There is just enough room inside this to use sockets, and I always prefer to fit a socket where at all possible. So I replaced the faulty device, and that brought this back to life. So that's all that's in these, just a series of sockets for the ROM modules, buffer chips, and then a bit of glue logic. Most of the decoding is done actually inside the ROM modules themselves, so there's not a great deal in the actual drawers. The sockets are not all the same in the way that they are decoded, and so it allows the HP to basically address them with very simple decoding logic. But very simple board. There are 2 of these. There's one for the LPU as well, the mirror images of each other. You can see I haven't cleaned this one yet, but I'll get this reassembled. We can refit the ROM, and we can now start running a bit of test code. So I've reassembled the drawer, and this is quite a clever design really. The modules obviously plug into these slots, but if we look on the underside of the module, you notice we've got this arrangement, this strange cutout at each end, and they are to prevent you plugging this into the wrong slot in the drawer. So you have these matching shapes on the drawer itself, and they will prevent you plugging the module into the wrong slot. So they essentially engage with the cutouts in the module, and that means that each module is identified with a symbol, so in this case it's a circle. You can only plug these into the slots that are identified with a circle in the drawer. If it's a square, it will only go into the square. If it's a triangle, it will only go into the slots identified with the triangle. So quite a clever system. So in our case, what we want to do is plug this into one of the slots that have the circle. And so they just basically slot in like this. The drawer then slides into the side of the machine. This goes on the left hand side. I get this plugged in. And if it's now working, then when we boot up the machine, it should go straight into the test code. So I'll get this plugged in and move the camera so you can see the screen, and we'll see if it actually works. I've got the ROM module plugged into the machine. We'll try and power it up and see if it comes to life. We heard 2 beeps. It's a good sign. That's what it's supposed to do with the test cartridge fitted. Turn up the brightness a bit and wait for the screen to come to life. Okay, so I'll turn off the lights so you can see this a bit better. And it's gone through the PPU self-test, and you can see that's passed. The LPU has passed. It's now doing the RAM test. This does take quite a long time if you have RAM cards fitted, but I don't have the RAM cards plugged in at the moment, so it will go through both blocks of RAM. You can skip this if you press the stop key, it will go straight through. And at that point, if you have the tape drives fitted and working and you have the test tape in the drive, you can run some binary programs that give you far more testing. So it's now testing the video RAM area of the system, which is why it's causing this odd behaviour. We're getting some strange display, but most of the flickering you're seeing is because of the usual camera shutter speed issue. So it's not really flickering in real life. Takes a little while to complete, but you can see there is some fairly odd looking artifacts on the screen that shouldn't really be there. Now, I did mention these previously in a much earlier video in this series when I'd forced the system into graphics mode and I'd found an issue with the graphics card. So you can see now it's passed the test and it now wants us to select a particular test. Now most of these tests would be on tape, and I haven't got to the tape drives yet. Let's turn the light back on. So what I'm going to do now is take the ROM cartridge out, and I'm actually going to fit the graphics ROM cartridge, because the next thing I want to do is correct the fault with the graphics card. So I mentioned that it does have a fault. In fact, it had a couple of faults and I've already fixed one of them. It's fairly minor. It looked fairly serious. It wasn't doing anything at all, but that was just a fault on the board itself. Well, we've now got a more subtle fault, but it was again very easy to resolve. But I'll just show you what I found with the particular card in this machine. So I'll get the ROM cartridges swapped over, and the graphics ROM module we want to fit goes into the LPU slot, but I need to take out the test ROM so it doesn't keep going into the test code. Okay, I have the graphics ROM module fitted into the LPU drawer. I've got the drawer fitted into the machine, so we'll boot this up. Okay, and hopefully you can see it has come to life and it's saying it's ready for use. What I'm going to do now is try and demonstrate the fault with the graphics card. And so what we'll do is enter a very short program to just draw something on the graphics screen. Okay, I've got a short program entered, and I'll turn the light off and we'll try and run this program. So you can see that what the program does is draw a triangle on the screen, but hopefully you can also see there are a collection of dots on there as well, and they shouldn't be there. And that's what the fault is with this particular card, and it's consistent. If we clear the screen and we run the program again, you'll see that it does the same thing every time. So again, this is fairly indicative of there being a faulty RAM chip or some faulty decoding in the machine. Let's turn the light back on. So I'll take the graphics card out and show you what's causing this. So this is the graphics card. I already found one fault with this. There was this particular wire was open circuit and it was stopping the card coming to life. But what I then found was the dots you can see on the screen. I didn't see it as dots at the time because I wasn't able to run the machine, but I could see the raster had some artifacts in it, and that was caused by a faulty RAM chip, or this appeared to be. So when I took this out, I started testing the RAM chips. I popped them out of the board one at a time. They are in sockets. I didn't fit these sockets. You can see there's one missing here, and the reason that has been removed is the fault with this was actually the socket itself. And this particular RAM chip, when I looked at it, if you'll be able to see this very clearly, you can see one of the pins is completely folded under. Hopefully you can see that. And that's normally a sign that the pins just missed the hole in the socket, and whoever did that didn't realise and pushed it all the way in. And then ultimately over time it stops making contact, and then this particular device isn't working properly. In this case, the effect you see is what we saw on the screen. With this missing, it's just one pixel every so often is skipped. So what I found was the fault was the actual socket itself. We'll have a quick look at what I found under the microscope. And whoever soldered these in was a bit overzealous with the solder and put way too much in, and as you can see it completely filled the pin with solder, and it prevented the pin on the IC from going into the socket properly, folded it under, and then over the years with vibration, or even maybe straight away, it stopped making contact. You can see the board still gave some output, so depending on whether that wasn't even noticed or not would depend on what the machine was used for. But either way, I'll get a replacement socket fitted, try and straighten the pin out on the device, get that refitted, and see if that cures our problem. So I've fitted a socket to the board. Fortunately, when I tried to straighten the pin out on the IC, it snapped off, as you can see. So I have soldered it back on. That's now been refitted to the board. I have also found that one of the other RAM chips was faulty. They all had red dots on, apart from this one, which, as you can see, has a white dot on it, and this one is faulty. So again, don't know if there's an issue with that particular location on the board, or if it's just for some reason this device has failed because it was not compatible, or whatever reason. I've put a new device in, and we'll now try and run this up. I've entered the same program. We'll try and run this and see what happens. Turn the light off. So hopefully you can see that's a lot better. The dots have gone, and it's looking like we're getting the correct output. We'll try and run it one more time, and the program does clear the graphics memory before it runs, and as you can see it's consistently giving us the correct output. Turn the light back on. So I'm really starting to make some progress with this machine. It's coming back to life. Still got some work to do yet on the printer, of course, but really the next step is to get the tape drives working, and once they're working we can hopefully run a test tape in conjunction with the test ROM and carry out some more detailed testing on the various subsystems. At the moment we've just been working trying to get it up to the point where it will run well enough to allow us to run some test programs. So so far I found I guess around 20 or 25 faults. Not that many for a machine of this complexity. Some have been a bit of a challenge to get sorted out, but really the next thing to do is get at least one of the tape drives working. So in the next video we'll start working on those.